These are inequality word problems, which means it's going to be just like we're going to have a let statement. Of course. Hello. Yes. Yes. Okay. Am I recording? Okay. All right. So, solving inequality word problems. It's just like the rest of them. We're going to graph some inequalities because there are easy ones and there are difficult ones. Okay? So, this first one should be an easy one. More than exceeds greater than. So, again, open circle. This is going to be to the right. X is greater than 1. Remember I did the 2 dots is greater than 1 dot. Some of you are using that. Some of you aren't. You also have to be able to have your X on the right-hand side and write it the other way. So again, 2 dots are greater than 1 dot. X is greater than 1. Okay? So you have to be able to write it with the X on the right and X on the left. Okay? So more than exceeds greater than, I think that one is an easy one. This one's an easy one too. Less than is pretty much less than. X is less than, 1 dot is less than 2 dots. X is less than 3. Putting the X on this side, X 1 dot is less than 2 dots. X is less than 3. I know you guys don't like writing it the other way, but you have to practice it. Okay? And that's why I like the 1 dot, 2 dot rule. If you don't really like it, just tell me, say, Mrs. Lorenzo, I don't like that. Show me another way, and I will. I like that 1 dot, 2 dot. All right? X is less than 3, so shade this way. Make sure you put an arrow at the end. Okay. So the next part is where it gets a little tricky. Is greater than or equal to, at least, has a minimum value, is no less than. I'll tell you, all of these means greater than or equal to. Except look at these 3 words here. At least, minimum, no less than. Those all mean, it sounds like it means less than, and this one says it's greater than. Because if I say you have to be at least 16 years old to drive, what does that mean? 16 or older. You can't be 15 and a half. You can't be 15 in 10 months. At least 16. That means you have to be a minimum of 16 to drive, right? So it's going to be X. Now here it's not 16, it's 0. X is greater than or equal to 0. X is at least 0. So here we're going to fill in our circle. Greater than. X also has a minimum value of 0. X is no less than 0. Let's put our X on this side and try writing it the other way. X is greater than or equal to 0. 2 dots is greater than 1 dot, right? X is greater than or equal to 0. So, of course, because this is tricky, the Regents likes this one. If I said I need at least 3 kids to help me with the dance tonight, I need at least 3. Does that mean I'll be happy with 2? No. Does it mean I'll be happy if I have 5 kids to help? Yeah, because I said at least 3. That means 3 or more. Okay? If I say to my son, I want you to at least get an 80 in math if you want to do anything this weekend, what does that mean? That means I'm not going to be happy with the 79. Yes, Aaron. Sure. Yep, I will. Okay, so So at least means I want, that's a minimum value that I want. Okay? I know that if you really are struggling with writing it the other way, just copy it down and then we'll do that 1.2 again. I'll show you that again. Does anybody like really love that 1.2? Anybody use it in here and love it? You do it? Good. I got one person that likes it. All right, let's try the next one. The next one is less than or equal to, is at most, has a maximum value, is no more than. These all mean less than or equal to. So let's write x, 1 dot, is less than 2 dots, less than or equal to -2. Let's write it just that one way first. So this is another trick that I use. This little word at here means opposite of what you think. Because if you think at most people think it means more. Most means more, right? At most, at changes the meaning of it. It changes it to opposite. So if you think most means more, at most means less than or equal to. If I said at most 2 kids can go to the school store at once, what does that mean? 2 or less. If you want to take a third person, can they go? No. At most means 2 or 1 or 0. At most, less than or equal to. Now, if you go to some old movie theaters, you will see it'll say max 200. What does that mean? Right, the most amount of people. Now, when you go to movie theaters, it'll say maximum occupancy. They actually had some movie theaters that would actually use the greater than or less than sign, some older ones. All right, so let's try writing this one backwards. Let's put our x here. At most, less than or equal to 1 dot, less than 2 dots, and then -2 over here. X is less than or equal to -2. Circle the -2, fill it in. These are the numbers less than it. Okay? We'll practice that with these word problems, I promise. There's like every trick in the book with these word problems here. Okay. The student council votes to buy food for a local food bank. A case of 12 jars of spaghetti sauce costs $13.75. What is the greatest number of cases of sauce the student council can buy? That's what I'm looking for. So let x equal greatest number of cases. I'm just going to abbreviate it like that, just to save some time there. We're looking for cases of sauce. Okay. The student council can buy, if they use at most $216 for this project. Okay. At most. Again, in your mind, you're going to think most means more, but that little word at is going to change it to less than or equal to 216. I cannot spend $216.04. I cannot spend $260.52. It's got to be less than or equal to 216 at most. That's all I got in my pocket. If it goes over 216, I got to take some back. Okay? Does everyone see that? Less than or equal to? So that side's taken care of. Now we got to do this side. How much does a case cost? $13.75 per case. Where do I put that 12 in? plus 12. What's that 12 talking about? It says 12 jars of spaghetti sauce in a case. That's how many jars are in each case, and it costs $13.75 a case. Is it asking me about how many jars of sauce I need? Is that what the X wanted, the jars of sauce? We don't care about how many jars. All we cared about was the number of cases. This is called extra information to throw you off. We don't need that 12 anywhere. It's extra. You don't sometimes always have to use all the numbers in a problem. So that's it. If you put the 12 in, you'll throw off your answer. All right? So now I have to divide both sides by 1375. Go ahead and do that. What was it, Seth? 15.70, something, 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 right? So X is less than or equal to 15.7 cases of sauce. Now, if you go to BJ's and your mother gives you $20 to buy a couple cases of soda, and you say, oh, I can buy a little bit more. I have enough to buy 2.5 cases of soda. Is BJ's going to like split open that case and give you the other half? No. Right? You can. So here, you cannot buy 15.7 cases. How many cases can you buy? I can buy 14, but I want the greatest number I can buy. 15, right. So who can buy? The student council. Student council can buy at most 15 cases. Can it buy 14 if it wants? Sure. Can it buy 13? But I want to know the greatest number I can buy. It can buy 15. Now, some kids, you could write it different. You could say the student council can buy 15 cases or less. That's another good sentence. Okay? It cannot buy 15.7 cases. It cannot buy 16 cases. This next one was the one like in your quiz today. We have two integers. So we're going to have two let statements. Let something equal the smaller integer, because that's the last thing I said, the smaller. And I'm going to have another let statement that is going to be the larger integer. Okay. Since the smaller is the last thing I'm going to say, x is going to be my smaller. The larger is 6 times that, so that's going to be 6x. Okay. It says the sum of them is 49, or is less than 49. What does sum mean to do? Add. You have to show me on the side that you are going to add them, even though I know you're all can add them in your head. Is that right? 6x plus x equals 49. Is that what I want? This is a mistake some of you will make on these inequalities. It says, did it say it was equal to 49? No, it said it was less than. So you got to be careful because you're so used to doing equations now that you guys put equal signs everywhere. So less than 49. Again, oops, 1 dot is less than 2 dots. Okay, now you can combine your like terms with 6x plus 1x. 6x plus 1x is 7x is less than 49. Divide by 7, x is less than 7. Okay, so now we have to write a sentence. Find the largest possible values for the integer. So, ready? This is going to be a lot of writing today. The largest possible value of the smaller, it's like writing an essay today, integer is blank. Now, if you don't feel like rewriting that whole thing, we can do these little ditto marks. The largest possible value of the larger integer is. Have you guys used those little ditto marks in English before? It means the same thing from above. Okay. Again, on a quiz or a test, you wouldn't want to do that. You want to write it all out. All right. So who can tell me what's, for the smaller number, what's the largest possible value of the smaller number? Yes, John? So close. So close. Not 7, because there's no equal sign here, John. So it cannot equal 7. So if I did a number line here, here's 7. It's going to go this way, right? So 7's not on that. So what's the largest number on that number line? Not 6. Good. And then I'm going to plug a 6 in for here. So 6 times 6 is 36. The largest possible value of the larger number is 36. Okay. It's like writing a research paper in English today. You guys have a lot of writing to do today. All right, is everybody good with that one? Okay. 3 consecutive integers. So you're going to have 3 let statements. Remember, start out with let x equal my first. I'm going to abbreviate consecutive integer. X plus 1 is my second consecutive integer. And x plus 2 is my third consecutive integer. I like to box in my let statement just to kind of separate it from my problem. Okay. Says the sum of them. So sum again means to do what to them? Add them. Good. You have to show the addition on here. I know some of you can do it in your head, and I like that, but unfortunately, the Regents does not like that. They want to see it actually written out. The sum is at least 20. At least. Remember, you're going to think least means less, but this little word at means to change it greater than or equal to 20. Okay? I'm going to give you a minute. I want you guys to finish that one on your own. So that's going to give me 3x plus 3 is greater than or equal to 20. Minus 3 from both sides. Divide by 3. And what was the decimal, John? 5.6 repeating? Is that what everybody else got? Okay. So it says, what are the smallest values? So let's graph this. I think it's always easier just to try to graph it first. Here's 0, 5, and 6. 5.6 is going to be right in the middle there, kind of. Fill in that circle. Okay. It says, what is the smallest integer on that graph? First of all, is 5.6 an integer? No. So what's the smallest integer on that graph? Is 5 on that graph? No. So what's the smallest integer on it? 6. So you have to say the smallest integers are 5, and then the next one's, I'm not 5, sorry, 6, 7, 8. Good. John's got knows this. Okay. This is a perimeter problem. I like to fill in all the sides because I know some people on the quiz today didn't do that and only added 2 sides and not 4. So you got to be careful with that. Okay, it says it has a perimeter. The perimeter is at most 44 feet. Okay, again, that little word at, you think most means more. At most means less than or equal to 44. Okay. And the perimeter means to do what? Add up all the sides. You have to show me that you're adding them up all the sides. Now, another way of doing it, remember the formula 2w plus 2l is equal to the perimeter formula. We can do that formula too instead of saying all the sides. They are going to want you to use that formula again. Like they want that one. You'll just see it more. So 2 times the width, which is 4x minus 5, plus 2 times the length, which is x plus 7. Now, could you have said, if you wanted to, 4x minus 5 plus 4x minus 5 plus x plus 7 plus x plus 7? Sure. You could do length plus width plus width. I'm just showing you this because you will see that they use this formula, so I want to expose you to it. Now, just like our DCV, distribute, combine. So if I distribute, I'm going to get 8x minus 10 plus 2x plus 14 is less than or equal to 44. Okay, and combine your like terms. 8x and 2x is going to give me 10x. Negative 10 plus 14 gives me a positive 4. And then you're going to minus 4 from both sides. We finally have one to turn out even. Divide by 10. X is less than or equal to 4. Now, let's go back and see what it wanted. It says, write an inequality. We did. Solve the inequality. Did we do that? Did it ask us for the length and width? It did not. Did it ask us for the dimensions or the length and width? It didn't. So do we have to do that? No. You don't have to find the length and width. Will they mark you off if you do extra? No. If you want to go and find the length and width, it's totally your choice. But it did not ask that. It just said solve the inequality. We solved it. So in this case, you don't have to write a sentence. It just said solve, and that's it. All right. This next one is like one of those, I call these like these tricky kind of puzzle, almost like a riddle type of math problem. Okay? But the main thing is getting our let statement right. So let's start with let x equal. Lisa brought half of her savings to the bakery and bought 12 croissants for $14.20. The amount of money she brings home with her is more than $2. So I know that in my inequality, I'm going to have greater than or equal to $2. I'm going to have more than $2 in my pocket. Okay? Use an inequality to find out how much money she had in her savings before going to the bakery. How much money she had before going to the bakery. So let x equal money she had before bakery. I'm just abbreviating it, not using all the words just because it's a long one. I'm going to box it in here. Let x equal money she had before she went to the bakery. All right. She brought half of her savings to the bakery and bought 12 croissants. So she brought half of her savings. If I said x was the money she had in her bank account, how do I say half her money? 1/2 x. Very good. So she brought half her money. She bought 12 croissants for $14.20. What's the extra information there again? I don't care what she bought, right? That's extra. I want to know how much she spent. She spent $14.20. Am I going to add that to my money or subtract it from my money? Subtract $14.20. Now it's not so bad. But just like you got to kind of dissect it and then put it back into the problem. All right. So now this, what do? Add what to both sides? Add 1420. And I get 1/2 x is greater than or equal to $16.20. And now this is the tricky part. Some of you still struggle with this stuff. How do I get rid of that 1/2 x? What do? Multiply both sides. Very good. By 2/1. So whatever you do to one side, do to the other. It's called multiplying by the reciprocal. So I'm going to just finish it over here. X is greater than or equal to, what's 1620 times 2? $38.40. Oh, sorry. Yes, you're right. Sorry. Let me write that again. $32.40. Sorry. Now, you have to write a sentence. It says, how much money did she have in her savings account before she... So she had at least $32.40 in her account. She had at least $32.40 before the bakery. Now, could she have had more? She could have had $32.41. She could have had $32.42. She could have had $32.60. We don't know. It says she had more than $2 in her pocket. It depends on how much she had. Did she have $2.50 left? You know, we don't know. Okay, so she had at least $32.40 before the bakery. Going to that bakery, not a good idea. Has anybody ever, you're going to put the bakery down?